Welcome to Lesson 3 in Unit 23, Celestial Clocks and Calendars. In this lesson, students will work to answer the question, how can shadows help us tell time? In this lesson, students will use a sundial to observe how shadows change throughout the day. They will create graphical displays to reveal patterns in daily changes in length and direction of shadows. They will use models to explain how the Earth's rotation on its axis causes the sun to appear to move across the sky, which affects shadow length and direction. Students figure out that shadows change throughout the day. Longer shadows indicate morning and evening. Shorter shadows indicate midday. Shadows fall from west to east over the course of a day. These patterns are caused by the Earth's counterclockwise rotation on its axis. Students develop an understanding that shadows helped the ancient Babylonian civilization tell time. There are several opportunities for ELA, math, and social studies cross-curricular connections throughout the lesson. You can look for specific standard connections in the Unit 23 Teacher Guide. This lesson will take approximately 4 to 5 days to complete. For the Engage portion, you'll introduce the anchoring phenomenon for sections 2 and 3. For centuries, humans have used patterns of objects in the sky to tell time. You'll ask students how they know what time it is and how they think people told time before there were clocks and calendars. You'll ask students questions about their ideas about time and why they think people started counting time. You'll discuss timekeeping by the hour and by the calendar year with months. You'll have students watch a video of the changing position of the sun in the sky and of a shadow time lapse. You'll ask students to turn and talk and discuss some provided questions, and then have them record initial questions based on their observations on Post-it notes. You'll provide students with extra Post-it notes to record any new questions they come up with during discussions. The goal is to support students to ask multiple questions related to the phenomenon that they can use science to explain. You'll revisit the driving question board and add new questions and highlight any others connected to the learning goals of this lesson by calling attention to questions and noticings about sun movement, shadow movement, and how you could tell time from objects in the sky. For the Explore portion, you'll bring the class together and ask if they have any ideas about sundials. You'll explain to students that a sundial was one of the first clocks used to tell time, and let them know that they are going to make sundials to investigate their questions about sun, shadows, and telling time. You can post and discuss the sundial vocabulary card. You'll give each student a copy of a sample design for a sundial from the activity. Be sure to see the teacher tutorial for this activity. You'll let students know that they will measure the length of their shadows using the gnomon of the sundial. You'll provide instructions on how to do this safely and accurately. You can post and discuss the shadow and gnomon vocabulary cards. Students should record the length of their shadows on the Sundial Investigation student journal page. In the Explain portion of the lesson, students will engage in a class discussion. You'll invite them to gather and analyze their observations and learning from the sundial investigation. You'll use the provided questions to guide the discussion around how can shadows help us tell time. The goal of this class discussion is to synthesize student learning from the data they collected and turned into graphical displays. You will use the discussion to create the Lesson 3 summary chart. From the discussion, students should understand that people in ancient civilizations could use the sundial to mark hours and tell time. This allowed them to organize their days and plan events and gatherings. During the Explain discussion, you'll use the tutorial and activity instructions for the Earth's rotation modeling. These provide guidance on how to model the rotation of the Earth. This is where students will explain the mechanism for the patterns they observed. During the activity, you can post and discuss the axis, tilt, rotation, and apparent motion vocabulary cards. For the Elaborate portion, you'll have students read The Ancient Babylonians and Sun Clocks. As students read, you'll have them record their takeaways in the Culture Note Catcher student journal page. After reading the article, students will turn and talk and discuss provided questions. For the Evaluate portion, you'll have students complete the Sun, Shadows, and Earth Quick Check student journal page. To support student sense-making across the unit, orient them back to the driving question board. Ask, what did we learn about how shadows can help us tell time? And what new questions do we have? By the end of this lesson, students will have recorded changes in shadow length and direction during the day and used the data to observe patterns. In Lesson 4, students will figure out how the Earth's revolution influences the length of daylight hours throughout the year. For the optional Extend, students will recreate the human sundial activity. Students will record data on the Extend Human Gnomon Shadow Data student journal page throughout the day. For more information about this unit, visit myscipartners.com.